We have discussed that every object above 0 Kelvin emits thermal radiations in the form of electromagnetic waves. And these radiations do not happen at a single wavelength. Instead, the radiation consists of waves of all wavelengths, ranging, theoretically, from 0 to infinity. But if that is the case, then some radiations must be in the visible range as well. So why don't we see the thermal radiations? This is because the intensity, or the energy of emission, is not equal for the waves of all wavelengths. For a perfectly black body, the variation of intensity with wavelength is as shown. At a particular temperature, intensity of radiation is maximum, around 1 wavelength, which is known as the dominant wavelength of radiation. And most of the energy of radiation is carried by waves having wavelength in a particular range, around the dominant wavelength. Intensity of radiation, for other wavelengths, is very small, though it is not zero. At room temperature, that is, around 300 Kelvin, the dominant wavelength of radiation, and most of the energy is distributed in the infrared region. And the intensity of radiation, in the visible region, is very small. And that is why thermal radiations are not visible for objects at normal temperatures. When we start to heat an object, that is, as the temperature of object increases, the dominant wavelength of radiation decreases. Though, with an increase in temperature, the intensity of radiation increases for all wavelengths. But with increase in temperature, the contribution of the waves with smaller wavelengths increase. At around 1100 Kelvin, the wavelengths in the red region have sufficiently high intensity. And that is why the object appears to be red around this temperature. If we increase the temperature further, then around 3000 Kelvin, the intensity of radiation becomes high for all wavelengths in the visible region, and the object appears to be white. You must be familiar that white light is actually composed of all the colors or wavelengths in the visible region. Note that area under this curve gives the total power of radiation, which is equal to this term, as given by Stefan's law. So though the total power of radiation is simply related to the temperature by this equation, the distribution of energy over various wavelengths is not that simple. However, note that the dominant wavelength of radiation by a black body at a particular temperature is related to its absolute temperature by this simple equation, which is known as Wien's displacement law. Here this constant is called Wien's constant. So this law tells us that the dominant wavelength of radiation at a particular temperature is precisely equal to this term. And this shift in the dominant wavelength is predictable and is not a random phenomenon.